Okay, let me play the slides. So everyone can see the slides?
Yes.
Yes.
Okay, perfect. So thank you very much, Anuradha, for giving this opportunity. Very, very excited to be remotely presenting to the students in IIT. I've known IIT from a couple of my students who were working with me in Eindhoven when I was assistant professor in Netherlands, assistant professor of practice in Eindhoven Design School. And I was really impressed with the quality of the students who we were talking to and teaching. So I'm really excited that I'm given this opportunity to talk to you guys. So today I'll be talking about accessible LaTeX-based authoring tool for persons with visual impairment. But then I will not go into the detail of this paper which we had in Kai last year. I was talking about that this is the Kai paper from last year, but instead of going too much into the detail of this paper, I will rather talk about that why I'm interested in this field and how can we work with this community. Sort of more about design guidelines and socio-political and socio-economic aspects of working with this community. So I am Suleman Shahid, and I work as an assistant professor in Lahore University of Management Sciences. This is one of the top schools in Pakistan. I run a computer human interaction and social well-being lab here. It was a social experience lab, but now most of our work is well-being. I also am the faculty lead for the Facebook Innovation Lab, which is the first innovation lab from Facebook in Pakistan. I also run department's usability lab, and I'm also co-founder of a design studio where we offer design services to the businesses in Pakistan. So the Computer Human Interaction and Social Wellbeing Lab in LUMS, I'll talk about it. So our mission is to design people-centered, user-friendly, culturally appropriate and inclusive digital technologies to improve the quality of life and well-being of individuals. And you'll see here, we have specifically highlighted here design, inclusive technologies, and then well-being of individuals or citizens. And the heart of it is the individual. And I think one of the things you have seen recently, that whenever you design this intervention, that has to be very personalized based on the needs and the requirements and the emotions and the feelings, both the social part and the emotional part of the particular person. So heart of it, is that particular person who will be affected by the design, by the technology, because the well-being is actually of that particular person. Our interactive and learning a child computer interaction. Also got interested in HCI for D. I think same in India. When you live opportunities to work in the emerging market for the people who live on low-tech resources is really amazing. And being a part of that community, you can actually make some impact and make a difference. And other than that, assistive technologies, primarily has been my area of interest, even when I was working with children in Netherlands. And finally, I do find an opportunity to work with businesses where I provide UX and UX service design services to the businesses, because a part of my training before my PhD was in industrial design and design for technology. I've also worked for Philips Research, Philips Design, Philips Healthcare on designing this novel product and services, for the industry. So I have a lot of industrial experience, which has helped me a lot in my academic experience. So in terms of technologies, we mainly develop mobile applications. We are very active now in VR, AR, especially because of the funding which we received from Facebook Innovation Lab. We also try to develop tangible technologies. That's very close to my heart, but I don't find much opportunity to design something tangible. And of course, we try to design low-cost solutions for the masses, which are primarily mobile solutions, but sometimes you can actually think about different kiosks or other tangible stuff which can be valuable to the community. And taking this human-centered design approach in whatever we do. So coming back to my research, so I have divided my research after coming back to Pakistan in 4-5 different themes. So and I've divided that with the age group. So for the younger groups, mainly we're working on autism screening, because most of my recent paper this year in Kai is actually is a first of its kind paper, which talks about how can you screen for autism using interactive, playful, game-like environment in the home in a home setting, but then still being connected with experts anywhere in the world. So we work on that, and then we work with dyslexia. I don't know much about dyslexia in Hindi, especially the script followed in Hindi. But for example, dyslexia in Urdu is really huge. It's one in the world. It's 1 in 10 who are affected by dyslexia, and in Pakistan, almost nothing has been done in the past to screen for dyslexia. So it is highly likely that even when you are 18, 20, 25, you'll be dyslexic, and you will go with in the mainstream schools and education stream without being actually screened for dyslexia. So we're now working on that dyslexia in Urdu. Then other than that, we're working on aids for visually impaired. My talk today is also for this particular group. Then we're also working on anxiety and depression. Some of my recent work has been on anxiety and depression, especially for late teenagers who join universities and colleges, because the change both in their in their educational landscape, in their social class, because of the migration, because of the relationship, and because of so many other factors, is so huge that this group is heavily on designing for dementia. We're trying to design rehab technologies for dementia. And something which is going on from last couple of years is also designing, physical games for people who are physically disabled, so that we can engage them in a systematic way. So you're with me until here? We're on the same page?
Yes, yes.
Can you hear me?
Yes.
Okay, perfect. Okay, perfect. So if you look at this framework, I think almost everyone does it, So in also in the West, in the more developed context, people are working on this spectrum, and people have specialities, So in Pakistan, in my lab, we are trying to focus on all these areas, not because we want to, but because all these areas are very interesting, and then we have small projects running in this area. Primarily, my interest is with children, but we're trying to focus on all these areas. But I think in the developing context, one thing which is very important is that you can't forget the awareness part. So on the top of it, it's extremely important that we do something for the awareness, so which might not result in a decent publication. But I think one of the things which my lab has taken as a responsibility is that, for example, how can we make online portals? We can make videos. We can work with the community. We can work. You can use social media to raise awareness about these things, so that we have this mindset change and we have this inclusive mindset. So that has been a fundamental part of our extra time. We still want to work on awareness. We still want to work on mindset change. We still want to make sure we still want to affect, for example, policy. We work very closely right now from the last couple of years with the government to make sure that the basic assistive technology, for example, screen readers, are been given to every major Pakistani university and school. And so in this way, you not only try to develop technologies, but you also try to influence the policy, so that the technology is actually being accepted and installed and is being used in the places where they need to be. So in this way, you sort of have this sort of more system thinking than the product thinking, because when you think of a system as a big ecosystem, you don't not only want to build that system, but you also want to affect the policy so that the system is being adopted, that product is being adopted as a part of the larger system. So I think for us in subcontinent, particularly, or in any developing context, I think we need to take both things, hand in hand, so that we have a larger effect on the community, and our technologies are actually meaningful. Otherwise, I think in the past maybe decade, we have developed so many prototypes and we have done so much work that doesn't really translate into an actual use. And I think time has come now with a stable product and services, that we take a second step and actually start influencing government and policymakers so that these technologies are actually being used. So I think that's a very important part, which we as a group of designers and technologists should affect the policy making, because design-driven policy is one of the emerging areas all over the world. So I'm going to talk about, the talk is actually going to be about this topic, aids for visually impaired. We're focusing on 15 to 18. And, before I go deep into that, as I mentioned, I love to work in this area of technology, design, and and well-being. And there is a lot of discussion now that how can we move away from economics of numbers to economics of well-being. Economics of numbers is always, very this quantified approach that look where the best ROI is. And whenever you think about this, where the best ROI is, when people with disabilities don't really fall into that framework, because ROI from them is not that high in economic sense. But when you change this formula or framework from economics of numbers to economic of well-being, then every individual is meaningful and respectful and is part of community, and the well-being of that person extremely important, not only for us but also for the governments and the policy making. So you just can't really confuse that. Because they don't really have a big impact on the economy, or they don't really contribute to the economy. That's why we should not spend money on that. Because when you have limited money, it always goes back to this: what is more important than the other? And I think that's a very difficult debate to have. But for me, that is a debate which we also need to sell on the higher level when you want to work with the government. So why work with them? So I just want to throw some numbers. Some of you might already know these numbers, but the number is huge. Over 1 billion people in the world's population live with some form of disability. It's a big number. And between 110 and 190 have significant difficulties in functioning. That's a world report. 93 to 150 million people, and children of 0 to 18 have different kind of disabilities. And 93 million of those have moderate to severe. So when you look at this number is actually huge. So if you look at the world population, there are only 14 countries with 100 million plus population, and the rest of the world, all of the countries are actually below 100 million, which means it's a big number. Because we, India, Pakistan, Bangladesh, is a part of this upper group, where we have just way too many people out there. This 100 million doesn't really look like a big number. 10 million doesn't really look like a big number, because in our mind, the number we're aiming at is the overall population. But I think we need to look at it from a very different context. For example, when we say that there are 5 million people in Pakistan who have some sort of disability, which I don't believe in. I think it's a wrong number. We must have a higher number, because there was no census, systematic census, and we don't have a data which is can roughly say that we have 5 million. But then look at the population of Finland and Denmark and Sweden and Norway. There are actually 5 million people living there. It's just about the whole population of that one particular country. Tell them that imagine that the whole country population has some kind of a disability. And then you can think about it from a very different perspective. India, I was just Googling about it, and then estimates are that 21 million people have some sort of disability. And I compared that to the country where I spent about 12 years, is Netherlands. Their population is 17.8 million. So maybe from a perspective of 1.3 billion, 21 million is not a big number, but it is a huge number when you think that every person in this million is a human being. And that's a big number because we're talking about 21 million human beings. So I think that emphasis to go away from this number game and making sure that the central thing is the human life. I think that conversation has to take place when we talk about disabilities. And so why work with them? The number is huge. The violations of their rights are actually severe. So the chances that your rights will be violated are much, much higher when you have a disability. There's a high stigma in families, and they don't ask for any help. And that's one of the biggest problem. So, and then another problem which many of us don't really understand is that they're not all the same. Not every disability is the same disability. For example, if you're dyslexic, it doesn't mean that it will affect your your capacity to solve problems in an efficient manner. You can still be a great problem solver. It's just that you're dyslexic. So it doesn't. And for example, when you're autistic, there are some very specific skills which you can acquire. You're so good at it that people would love to have you both as in different companies, but also for very specialized tasks. Similarly, for visually impaired, they can acquire some very specific skills, and they will outperform almost anybody else, in their peers. So they're not all same, So and it's not their fault, their impairment. So we need to sort of differentiate different kind of disabilities, and then find a systematic way of designing for those groups. And that brings me to my discussion, which I will talk about in very quickly. I'll skip some slides because I think I would like to go back to my second discussion, which connects with my first discussion, which I just presented before starting this presentation. So this is the paper I'm going to talk about today. Again, numbers, because I think these numbers are extremely important. You just cannot make a case without throwing these numbers in. So world population is about 250 to 80 million who have some kind of visual impairment. And we all know that based on the current trends, that the number of people with visual impairment will only increase because of exposure to more digital devices, because of the pollution, because of the air quality, because of all other factors, because of the more transportation issues, the use of public transport and the quality of that. Would all those things, a low quality public transport, where we have exposure to the smoke and other hazard material, would only affect our visual impairment. So this number is going to only increase. Blind population in Pakistan, we don't know. Honestly, we don't know. Not very proud of it, but we have no idea. People think it's about 2.5 million based on some rough estimates of 1998. We again disagree. We think we don't have a right number. But I think the more interesting part is this number 2. If I was standing next to you, I would have asked what that number is, and I'm pretty sure no one in the group would have predicted. So this is a number that visually impaired student graduated in the past 10 years in my university. The top university in Pakistan, with one of the best engineering school in the world, in Pakistan, was only able to help 2 students to graduate from their science and engineering stream. There were more students in arts and liberal arts, but only 2 in science and engineering. And that's really problematic. And there's so many reasons. I'll talk about it. But WHO has said that assistive technology has become a basic human right. And for people without disabilities, technology makes things easier. For people with disabilities, technology makes things possible. And I think one of the reasons when we ran a survey that why it is the case that only 2 students were able to graduate from a top class school. And also it's the same situation all over Pakistan. There's no infrastructure to support people with visual impairment. There's no support at the university. There is inadequate technical support in labs for any scientific writing, including LaTeX. Scientific writing is a very tough job, and there is no systematic, support from no to expensive hardware and software. Pressure to move from STEM to arts. So there's a big pressure that you can't make a career in STEM So why don't you move to arts? How would you write mathematical documents? How would you submit your assignment in physics? How would you write formulas? How would you do all those technical tasks which are fundamental for doing your A levels, O levels, and your college education? So I don't know what the case is in India, but in Pakistan, there's a natural trend that after your high school, people would encourage you to leave this STEM track and move away from STEM and go to arts, so that you can actually write documents on paper and do a sort of more low tech, lo-fi stuff, and still able to get a degree, and jobs. Who cares? So we did a big survey in Lahore, and these are the things we found out. Other than that, we did also a big comprehensive meta review of existing tools, technologies, and learned that existing tools, there's a high cost of commercial products for example, accessible math. There is an incapability of existing text-to-speech systems to support mathematical content. And mathematics is the heart of any STEM education. So if you can't write and type and understand and read maths, it is almost impossible to continue education in STEM. There is unavailability of quality and accessible interactive editors for PVIs. So if they're really people with visual impairments, that's another big issue. So we did a lot of analysis. We looked at different tools: Overleaf, Shield LaTeX, TechLips, TechMaker, Tech Studio, and Chat Infinity, which is an expensive tool. And we looked at that. How do they support navigation? How do they support editing? How do they support debugging? And are they compatible or not with some of the top of the notch text-to-speech engines? And it turned out that the gap is immense, is huge. So absence of even single fully accessible tool for authorization and presentation of scientific documents. They're all dependent on external screen readers. And because of the compatibility issues, these screen readers do not work with many of these softwares which we need for writing scientific documents. Even Microsoft Word, until the last year, now they have done quite a few improvements. Until last year, failed badly when it comes to reading mathematical content. There are lots of dependencies. LaTeX is preferred, but not very accessible. And more important thing, as a UX designer, is that the UX is completely broken. So imagine the scenario. Now you have developed a tool which is partially accessible, but to get that tool, you have to visit a website which is completely accessible and is not friendly for people with visual impairment. So you'll find it difficult to find the tool. You find it very, very difficult to download the tool. You find it very, very difficult to install the tool, to set the path, to set the library, to make it up and functional running. And only once you have done that, yet the tool itself is accessible. I think that, and then after that, the product you produce out of that tool, either a document which is PDF or any other document, is also not accessible. So you see here, you're all a student of design and technology, in terms of service design, in terms of this customer journey mapping, the journey is completely broken, because the first part of journey of downloading and installing is completely broken. And second, and the last part of the journey, which is actually producing a final output, is also broken. So many people try to fix the intermediate, and the central path is that try to make the tool accessible, but they forget the journey where you have a big interaction before using the tool and big interaction once you have produced and document out of that tool. So you want to fix that part also, because that's our responsibility as a designer. So the research questions were that is the available technology accessible enough to author and publish documents comprising advanced mathematical content? How LaTeX debugging impacts the user performance? How does the narration of mathematical content in natural language facilitate the visually impaired? And does automating the process of accessible PDF generation is a step forward towards more inclusive technology? I will not talk in detail about the PDF part. We have just submitted a paper on PDF in DIS, but I just want to highlight what do we mean by that. So the last part of the customer experience or user experience is that you generate a PDF, but then PDF is not accessible, which means all the formulas which were embedded in that PDF, when you open that PDF, are completely inaccessible, and your text-to-speech engine cannot read those formulas. So And now you know that if you want to submit a paper even to Kai or another top conference, for example, Assets, which heavily focuses on assistive technologies, they don't allow, they really force you now that your PDF should be accessible. But even for me, designing and producing that accessible PDF out of Acrobat or out of any other tool is a very, very hard task. So what we have tried to do in our project is that every PDF which is being produced out of that tool is accessible so that it works for everyone, not only for people with visual impairment. So the goal was software that enables blind users to author. The primary goal of the lab has been produced a working software, not a prototype. Make sure that software is up, functional, running, give it to people so that then they can use it, and hopefully we will get a publication out of it. But we don't, from the last couple of years, my target, although it can be very costly from a career progression point of view, but I've decided that whatever we'll do, most of it would be mature software so that we can actually make it happen and not leave things in the middle where we have a prototype, we have a publication, but there's no incentive to continue with that. And I think maybe some of you might want to take that path also, not too early in your career, because you need publication for your career path, especially when you're a researcher. But I think at a certain stage in your career, you might also want to think about that. Let's forget prototypes and let's start making something which is actually downloadable and installable and usable. So we developed a lab, a standalone plug-and-play open source system that supports assistive debugging and correct description narration for mathematical content, hence offering blind users independence. Independence is the key here to create and authorize later baked documents, and also to download and also to produce final product. So we have, I'm going to quickly go over it. We have editor accessibility, we have assistive debugging, we have math mode, and we have PDF accessibility. So the complete editor is accessible. I'm going to show you here.
Build started. No error found.
So PDF document is generated.
$\frac opening curly bracket 1 closing curly bracket opening curly bracket 2 closing curly bracket $. Empty line. Build started. Missing $. Inserted. At line number 18.
So we have done two things here. In certain cases, what we have done, we have automatically tried to fix the errors so that users don't have to fix them, but then we have told them that how did we fix it. And in the other cases, what we have told them, we have given them the error, the line number, and automatically, if there is only one error, we automatically move them to that particular line so that they don't have to navigate. So the idea is that how can you reduce the cost of navigation in this case as much as we can. Then we have a math mode in which we actually can type a basic math, but then also to produce an accessible PDF document. Look here.
Build started. No error found. Start of matrix opening bracket. 2 by 2. 1, 2, 3, 4, closing bracket end of matrix. Integral ellipses integral fraction numerator 1. Over denominator 2. And frac. dx. Summation underscore n is equal to 1. And sub. Raised to power 2. And power. F open parenthesis x close parenthesis integral underscore 3. And sub. Raised to power infinity. N of z. There exists y is less than n.
So in this case, every document you produce, the mathematical narration is, we have written a new a middleware, a utility, which actually translate this LaTeX document into this narration table, and then that thing is being given to the TTS system, and TTS system then says that. And then the last thing, we have done the PDF accessibility, and what we have worked on all international guidelines, which make PDF accessible, automated generation of PDF accessible, all the mechanical tagging of mathematical content, auditory warnings we give. Whenever you break any accessibility standard, the system give you an auditory warning that you are not followed that particular standard. It actually facilitates both sighted and blinded users, and then actually the system has been more appreciated by the sighted users than the blind users actually. So this is a PDF.
Attack PDF.pdf-adobe Acrobat Reader DC document. E x2 plus 1 x y x2 y p1 n equals 1 and 2 and q and t equals an s and t.
So now in this case, the TTS is actually interacting with Adobe Acrobat Reader, but because the PDF is accessible, the metadata is stored. That's why you can understand it very well. And then we have a tagged PDF also, and you will see a clear difference.
Square root and sine radical x raised to power 2 n power plus 1 n radical fraction numerator x over denominator y n frac is greater than and equal to fraction numerator x raised to power 2 n power.
So in this way, you can clearly see that there is a huge difference between tagged and non-tagged PDF. So it's a quick thing you developed in Java using Eclipse, using Microsoft TTS library. The engine we're using MECTEC, which is a standard thing, and then we're also using SOA architecture, which is a normal thing. We have an editor, we have a LaTeX parser, we have MECTEC, and then we have a TTS system, and then we have a compile time and runtime adders as well. So key contribution, we have proposed a new improved text-to-speech system. We have done an accessible debugging platform. Debugging is being done in a very systematic manner, so that we try to predict as well as we try to anticipate, and then help user in automatically fixing errors without bringing more confusion. That's a very important thing, because whenever you try to fix things automatically, sometimes you introduce more confusion. So you have to find the right balance that your automatic fixing doesn't really actually confuse users more. And then, of course, we have worked on the PDF system. Tested the system with 18 completely partially blind users. They were all, one important thing to keep in mind, that they were all users of LaTeX. So they were not the users who have not seen the LaTeX before. They were all LaTeX users. And then we tested the system with them, and participants were successful in resolving 75% without LAP and 89% with R2, which is a great point, that the error recovery was much higher. And very quickly, I'll talk about some of the results. More or less, they were spending less time with ALAP. They had the error rate was also less in the case of ALAP, as you can see here very quickly. And error recovery was really very good with most of the participants, as you can clearly see in the case of ALAP. And that's where we do have some outliers, and a couple of outliers, but you can imagine that that's pretty common with this very specific user group. Overall, they were very excited in terms of perceived ease of use, usefulness, attitude. System accessibility was, as you can see, system acceptability, the second last row in the table, is really high, and I think that's one of the things which we worked on very hard. Some design decisions we have taken, for example, speech-based output was a key for blind users. And another thing which we learned, that the blind users do not like ambiguity and therefore should be informed about every micro level action. So when you fix things for them, you have to tell them that we have fixed things. They don't want complete control. When we were working with our designers, very often they thought that we don't need to inform these people because they can't see. Even if they can't see, that they want to have a complete control over the system. Any change under their control should be informed to them. So that's a very important thing. Blind users also require keyboard shortcuts for ease of control, but then the right use of keyboard control, and especially making sure there is absolutely no conflict with any of the tool they're using, is important, because if there's a conflict, even a partial conflict, that will destroy the complete user experience of the software we're trying to build. In terms of debugging, automatic error narration and redirection to the exact location was a big thing. This is something which we think can also be used in almost any tool any programming tool which we develop for visually impaired, because it works for LaTeX. It means it should also work for any programming environment which we want to customize for visually impaired. Narrating the mathematical content precisely in natural language was really great, and I think this learning can also translate that how can you narrate the code to the people when they have to program, especially the visually impaired. And another thing, the last point here you can see, we have designed our system in such a way that the system should be usable both for the visually impaired and sighted. So all the extra features, all the big accessibility layer which we have introduced on the top of that should be disabled very quickly, so that it should not annoy to people who are sighted, because they don't need TTS. Okay, disable TTS with one click. They don't need extra navigation support. Okay, disable that with one click. They don't need automatic prediction. Okay, stop it with one click. So the preference engine should be designed in such a way so that the sighted people can also make good use of it. So that's also a key design point which we need to keep in mind, that we should not force sighted just because we have designed for visually impaired that all the features should be or would be used by the other group. And then I will come back to the final part of my discussion, and then I'm happy to answer questions. So I'll just take 5 more minutes. So there is no rocket science. What we have developed, the tool works. It was not easy. It took us a year. Lots of co-design sessions. The process was very rich, which I did not talk about it, but we had lots of primary workshops. We had a few focus group sessions. After focus group sessions, we identified the pain points, and after that, we came to know that the biggest problem is, of course, physics and maths, and in physics and maths, it's producing scientific documents, and that to submitting those scientific documents in a form of PDF to their college professors. And so there was a complete journey behind it, that how did we end up with this system. It was not a rocket science. It was not easy, but it's fine, and that it's not something we're very proud of it. We're just proud of it. That's fine, But more important things here are technology brings hopes, and respect the hopes, and that's something I'm very emotionally connected with this. What we do very often, especially our students and many of our researchers, they experiment with this group. They design new technology. They go to this different schools. They go to people with special needs. They show them this magical new system, which is half cooked, partially working. We use Wizard of Oz techniques. We fake things, and we tell them, look, this is how it's going to impact your life. Do you like it? They will say, yes, we like it. And then we all write a cool paper, let me, I think this is, I will have to skip it. Just give me a second, and I will come back to you. And we never go back to them, So I think we raise their hopes. We give them this chance that their life can be changed. But then for us, it was just a prototype. For us, it was just a project. And for us, it was just an interaction to get our project done, to get our publication done. So I think we need to be very, very respectful about our commitments. We need to we need to be sure that there's a very strict ethical protocol. We need to be careful with a single word, every single word we tell them. We need to be very careful to tell them that the system is not ready, would not be ready in the next 2-3 years, and you're only going to help them so that the system might work for the future generation. So I think that's a key part. We learned this thing in a hard way. One of the visually impaired student did tell us that people come to us and they never ever give something which actually change our lives. Are you gonna go away and never come back to us? And then I promised at that time that when the project ends, the system would be installed on your computers in your university. And of course now the system is installed on the computer in the university, but then this mission became a part of the project because it was embedded right in the DNA that we have to deliver a working product to the community. So that's I'm sure you're aware of this, but please make sure that this ethical part is well integrated in your research and design. They're all different, you don't know them. Try to know them. And we have lots of misconceptions, and we have lots of these associations associated because of the dramas we watch, because of the movies we look at, because of the stories we have written in the books. But they're not actually like those stories and the dramas and the movies and everything else. They're very different. Their emotional needs are very different. They're stable. And many of us have heard stories about them from our parents, but they have been exposed to technologies in 21st century. So they have different expectations. Try to know them. Try to spend as much time as we can with them, and forget the technology part in the beginning. Uh, Try to be their friends. The real empathy, that you try to put yourselves in their shoes, not the sympathy, but the empathy should be there, so that you are connected with them. You should try to understand on a very basic level. If you cannot deploy, do not promise, please. Like, I think maybe with Anuradha, we can work on maybe a code of ethics, especially in the developing context, that uh, how how our students should go to the field. What are the 10 golden principles and the golden rules our students should follow when they go to the field, and then that checklist should be there. And we will never accept a project as a faculty member if that checklist is not being entertained. And that checklist is not a typical institutional review board IRB, but has a more deeper understanding purely from a design field, technology field, so that we show empathy for this group. If you know it would not work, make it clear the first day. So again, about the expectations. If you know that this is not going to work and this is Wizard of Oz, don't really imagine that just because they can't see, they would never know. They would know. We just did a project with them where we designed a game, and the game was completely working on Wizard of Oz. It was an audio game, and they knew after maybe a few minutes that the game is fake. They did not say to us, but when I inquired about it, they said, डॉक्टर साहब, गेम 2 नंबर था, लेकिन कोई बात नहीं, मैंने कहा चलने दो. So they try to respect us, and they don't say these things. But you need to find a mechanism so that you go deep, find a more deeper emotional connection, so they don't try to please you, but give you the right answers. Because you can't have this right type of eye contact with them, and sometimes the communication is a little broken. There's a huge communication gap. Try to fill that gap. Do not leave them in the middle. Plan for the long-term support. And that's another important part. Even when we try to develop technologies for them, we give this thing to them, but then there's no support afterwards. And that technology might not be usable and useful immediately. So they might need more long-term interaction, even once the technology, even the prototype has been deployed. So think about when you write a project proposal, when you work on your master thesis, when you work on your project plan, when you're working on your PhD project. It is fundamental that as a part of your proposal, if the deployment is a part of the proposal, the post-deployment interaction should also be the part of the proposal. Again, not only from the ethical background, but also to look in a more detailed manner how they interact with the technology. And I think if you look at the body of research, we have a lot of data on how these people think. We have a lot of data on how do they interact with technology, but we don't have lots of data that what happens when the technology is being deployed and they're independent with that particular technology. So I think that's another interesting area to focus on for the future. We always need to think about multi-method long-term approach. Give them the tool, opportunities to think about your system after the moment. That moment is that particular time of evaluation, because once the project is evaluated, we leave. But then can we think post-moment strategy? And can we use multiple methods at all stages? Can we use focus groups? Can we use participative design? Can we use design props? Can we use auditory design props? Can we use audio recordings as a daily diary method for them? Any other method to understand them? And then can we employ some of those methods also in the evaluation phase, where we go beyond usability testing and try to employ all those interesting techniques which we had employed in the user research phase, and then look at the impact of these things in the pre and the post phase. And I think this multi-method approach is a fundamental if you want to design new technologies for this very specific group. And pace of evaluation, we are always in hurry because we have to have that many users and that many numbers. For this study, we took a different approach. For example, yeah, I don't have it here, but we took a very different approach. We had a team of RAs for 1 week who were pre-trained for this project, and then we tell them that we will never be in hurry. We will let them do their work on their own pace, in their own way, and we will develop an ecosystem around them, around this evaluation. So I think that's very, very important that we let them finish in a systematic way. Then the developing context is key. It is important to know where do you evaluate. I don't know about IIT, but even LUMS with the top private university with almost every great resource you can think of is here, but we're still not a very accessible campus. So when we invite these people to LUMS for 1 week long testing, we need to make sure about every single accessibility issue for these people. Our toilets, not very accessible. Wheelchair can't go in. How do they move on the stairs? How do they go to the lift? How do they sit next to the computer? All other small micro factors. How do they enter from a gate where the bus would park? How would they go for their lunch? Everything has to be planned. In Netherlands, we never thought about it because the whole university and whole the ecosystem was there to support it. From the point they will depart from their school, to the buses, to the roads, to the pathways, to the lunch, to everything. But in Pakistan, unfortunately, we don't have such a system in place. I'm not sure about India, but this is something we need to keep in mind when we design for these systems. Our RAs are not trained. They don't have the right type of empathy that which words can we use. Can we tell that you're blind? Can we tell that you're visually impaired? Can we tell, oh, you made this mistake, stop here, let me help you? Do you want to use the word help? So this vocabulary to be used during testing is extremely important. That will actually help you in building the right connection of friendship, then the connection of authority, of mentorship. So how would you use that is extremely important. Then logistics. When you want to do a 2 weeks long study with this group, you cannot imagine that managing 20 people, how difficult it is. I'm sure some of you have done these projects with these people, with this group. It's extremely important to make sure that we are rehearsed. They don't really have to face any of the problem. They have, believe me, and you know better than me, was in some certain scenarios, they have seen enough in their life. So they don't want to have on the top of their regular life another problem. They have to manage this evaluation and have to go through all these problems. And finally, we need to make sure that we train sighted guides. So we need to have for our evaluation enough people who can help them. I'm going to skip that part. We have lots of future plans. We want to go further, but I'm going to stop here with this slide. Finally, that whenever we think about people with visual impairment, we only think about, most of the time, we think about a serious purpose, especially in the developing context, because we have so many problems. Not many people have tried to solve our problems, so we have to focus on our problems. And when we think about solving problems, and the most important thing comes in, that how can we improve the education? How can we improve the healthcare? How can we improve the financial part? But we don't really pay so much attention on the entertainment part. And entertainment for this group is even more important than for us. So one of the projects which we have started working on is how can we design games for these people.
तरह की कोई गेम मिलती है जो मुझे फीडबैक दे, तो आई आल्सो लाइक टू प्ले। बेशक होता है, मैं जब खेलता था इनका थ्रेड बहुत कूल लाइक तो फिर उनको एज एडवांटेज होता है, इक्वली खेले तो फिर मैं उनका वैसे।
He was saying that the sighted people always have an advantage, so we need to make a game where we can play together.
ये दुश्मन है थोड़ा सा बाद में, ये इंटरेस्टिंग है थोड़ा सा, इसको तरीके से पकड़ना है, ये भी इंटरेस्टिंग है इस गेम में, ये मजेदार है.
So he was saying that we need to make a strategy to capture the enemy. Yeah, so I'm gonna skip here. Thank you very much for your time. I hope I'm open to the questions.
Yes.
Suleman, can you switch your camera on? Yeah. You switch this camera.
I hope that I was you were able to listen everything. I hope there was not many delays.
No, it was nice. Quite
Okay,
nice.
perfect. Okay, perfect.
Questions?
So questions, please.
Wait, something I technical maybe, but should I repeat it?
Why don't you come here and come here? That will be easy.
Okay.
Bend into the camera.
Sure. Yeah. Hi.
Hi.
Right. So
Not in the camera.
I'm here. Yeah. In the software add-on that are created for LaTeX, there were multiple features. When you're evaluated, did you all consider evaluating each feature separately, or just this thing as one set?
No, so we had this control where we had how few participants would test the one feature first and the other feature second, but there was also a sequence part. So if you look at, there's a very specific sequence of producing a document. So in terms of sequence, you first have to write a LaTeX code, then you have to compile it, then you have to produce PDF, and then you have to read that PDF. So we did not want to break that flow in terms of our feature list. So you have to go through this journey of producing the document, but then on the top of it, we had some separate features. For example, you can switch on TTS, you can separately work on the error recognition. So these things were tested with at an intermediate manner, but the high level feature lists were tested in a sequence.
Right. Okay.
Yeah, but just a quick thing. Why do you think it would be interesting to test these features separately? Do you think we can get different insights?
I think what you answered did clear it up a bit for me. But I was thinking,
Yeah.
I mean, in one sense, each feature may get a different response from people.
Yeah, and it did. So we did not report that in the paper. So there are some very interesting correlations and some very interesting no explanations also. So sometimes a person who was very comfortable with the accessibility of the PDF, or maybe was very comfortable with using some of our shortcuts, was still not very comfortable with the way error handling was done. Right, so you can. I completely see your point that you can imagine that these features sometimes might have a decent correlation that one would affect other, but sometimes there might be no relation. So from that perspective, it does make sense. Yeah,
Right.
Good point.
And more, I think, because in terms of the math mode is something that
Yeah.
I'm not very familiar with in terms of how it works in LaTeX, or whether there would be some training required for visually impaired students to start understanding how the TTS part worked.
So TTS part, no. Maybe for training would be required that how would you type mathematics in a very specific LaTeX format. So that would be required. But most of these students have had a background in maths and physics, so they all knew how to read a metrics or how to read any basic formula. So from that perspective, and they were all aware of how a TTS works on Microsoft Word, and they had lots of problems with that. So from a comprehension point of view, I think there was not much training required. From a typing point of view, yes, there was a training required.
Mm-hmm. Right.
Yeah.
Yeah. I think any more questions in this area? I'll come back.
Sure.
Adding to that, like normal users also face, like, because there are many complex syntaxes in LaTeX, like when you write mathematical equations and stuff. So it becomes quite long. So we generally use autocomplete or suggestions from like if you type on LaTeX. So were there any such features for them?
Your name?
Jebra.
Very good question. Excellent point. There was this confound or dichotomy in a sense that on the one hand, you want to support them with a lot of auto completion. But on the other hand, every auto completion has also needs to be informed to this group so that they know what has already been done. And that's a very interesting design problem, because because this actually increases the amount for the TTS to say a lot more than they were expecting, and that also brings ambiguity and confusion. So in certain cases, we tried to autocomplete some of their formulas, very basic formulas. Some of the statements, for example, they forgot colon, they forgot $sign, as you've seen also. We did that, but we did not go for complex auto completion of mathematical equations. First of all, we were afraid that this will increase ambiguity. And second of all, I think it requires even more deeper research that how this auto completion should work. So this is a very interesting future work that how would you design for this group purely for auto completion. I think that's a very interesting specific research question which can be extended, that how would you design for auto completion for this group, because that auto completion is much more complex than auto completion on Google search.
Yeah, because it's quite continuous.
Exactly, but on a syntactic part, I think auto completion can work. For example, if there's a pure minor syntactic addition in terms of underscore, in terms of parentheses, or in terms of colon, I think that they can handle easily.
Okay.
But a smart, but sort of smart AI-driven auto completion would be hard, where you can say because this user has been adding always a square plus b square c square, so it makes perfect sense that automatically after equal to I add c square, for example.
Yeah, because in overly there's no AI-driven suggestion.
No. And I think I can completely imagine for the right reasons. And no, there is a lot of work happening right now in mathematics that how would you go for this AI-driven mathematical completion. And I think that's that same completion. I think Grammarly is doing a very good job in adopting the tone of the language. So Grammarly knows that how you use a particular verb and how do you use active voice and passive voice, and then the suggestions are more contextual now. I think that same approach can also be taken for mathematical narration.
Thank you.
Yeah, thank you.
Any other questions?
I did have one more question. I mean, it's maybe a little vague, but so I understand the approach of accessibility design. I mean, keeping in mind universal design and accessibility would then be an add-on to what already exists. But when you were looking into this area, did you find that there could have been fundamental changes to the software of LaTeX, which would maybe allow visual impaired users more ease?
I think it's a very, very good point also. I think a more open and brave research should have been that how can you rethink about LaTeX? And I think that's a very interesting point, and we did rethink about it when it comes to our online system which we're building right now. So we were trying to see that there's some fundamental limitations with the way our software works. Our software relies on a very specific engine that converts a very specific LaTeX syntax into an executable. So the assumption actually that the whole project begins with a big baggage, and that you have to carry that baggage with you, when you take that approach. And when we were thinking about designing a completely new editor for visually impaired and online environment for scientific document writing, we did think about this approach, and we did experiment about an online environment where you don't really have to do things in the way you were doing in LaTeX. And then second thing, which the question, it was connected with a question which was just raised, which I also liked very much, was that how would you bring this auto completion part in? I think this smart auto completion is very important. This AI driven base system which can predict and can complement this online typing and writing, I think is extremely important. And I think that is something which can fundamentally change the way we write the LaTeX code. And secondly, I think going back to the basic thing is that how can we maybe make Word more accessible, or that style of typing more accessible, so that you don't have to actually go to LaTeX. Microsoft, that Microsoft is spending a really lot of money on that. If you look at the accessibility of Word 2 years ago and today, and the TTS accessibility 2 years ago today, it looks like that some magic has happened in that domain. So I think they have understood that the more you push towards accessibility, the more you improve your technology for the larger audience. Yeah, but good point. Very good point.
Yes. So Suleman, thanks. If you had a couple of minutes for a couple of more questions from me.
Sure. I have time. Sure.
Yeah, sure. So first of all, thank you very much. It was a wonderful talk and nice to see your work. I think it is really fabulous. I had 2-3 questions. So I had some questions about this. Maybe we can discuss afterwards when we meet.
Sure.
But about your work that you presented. But I think the more interesting point that you raised, I sort of am trying to ask that one question, which is that you said that we should do projects only if we can sort of implement them in some way. Okay, and I'm asking this question particularly if coming from a design school. Okay, because in fact we're just submitting a proposal coincidentally in the accessibility space, where we have specifically said in the proposal that we will come up with 100 ideas, 20 prototypes, and 5 deployments.
Sure,
okay, so that's what we are saying in our proposal, because in some sense this is like also our experience that we work on hundreds of ideas, and if we actually were to think about implementing each of those ideas, we will probably not be able to generate hundreds of ideas. We'll probably able to generate only 5 ideas.
Sure.
So that's one problem. Second problem, and this is a question that is similar to a question that one of the students asked Nikki Dell day before yesterday, because she was here in this course, and the question that the student asked her was, should we be working in this space? Should we be working on current technologies, or should we be working on future technologies? Now, when we are working on current technologies, doing the kind of stuff that we are doing is relatively easier. But if you are working on something that is far out in the future and we don't really have anything with us right now, then how do we work on that technology?
Yeah.
So, and does that mean that should we not work on something that will be real 10 years from now? Or what do you think?
Oh, very good. Excellent point. So let me first clarify also the disclaimer. So when I say, you should work on complete systems, there was really me talking to myself, also telling myself that at a certain stage in your career, I think the time has come that you're more concerned about the completeness. I'm trained as an industrial designer, so I'm like 200% agree. The ability to produce as many ideas as possible, and then playing in that design space so that you have some rich insights, and then you make prototypes. Absolutely, I don't want to give the wrong message here that I don't agree with that. That's what exactly I do in my HCI course. That's what I do in my early design course. I think one of the things we are not doing very well actually are inability to produce design ideas. So we have more methods to conduct user research and evaluate, and less number of methods to actually work in the design inspiration space. So we have not innovated that much. We have more restrictions in our design ideation space, and that has become a fundamental problem in the way we actually ideate and then come up with different methods, because all the way we go to the sticky notes and start producing ideas in a very a 20th century method. So I'm a big fan of even bringing more methodological innovations in ideation, so that our ability for our students to think outside and produce more ideas, and more importantly, use existing technologies and have a big extension to that, so that the implementation could be also fast-paced. And that's what I said. Don't do it when you're a graduate student or a PhD student, but maybe later in your career. That makes perfect sense to do experiment with these things, when you're not worried about the tenure. Going back to the second point, again, a very important question. So if you look at a lot of the way assistive technology has always been sold in the last 20-30 years, the notion has always been, when you work on assistive technology, you try to solve a future problem. So very often when you try to work on assistive tech, you try to bring technology which was not there, or which was not there in that particular shape. So you really have to push existing technology and then make something new out of it. So I think that part would always be there. the innovation you see on accessibility, even in the case of iOS devices, in the case of Android devices, they try to go beyond what an iOS device normally offers. Something they have an extra layer on the top of what was being already offered. So I think we need, if you ask me, I like to work in both spaces. A part of me do think that we need to have something which can go to the field tomorrow morning, and a part of me do feel that forget what will happen in the next 10 years and think about ideas and future problem solving. And again, I'll also try to sort of explain that from a very different perspective. I have spent about 10 years in a design school, and about 7, 8 years in a computer science school. I think the way a design student is being trained to solve problems is very different. So we just cannot ask them to wear a computer science lens and start solving problems from that implementation perspective, or from a past or present perspective. They should be also allowed, because of the methodology they're exposed to think beyond, purely from a design space. Similarly, a computer science student is being exposed to for implementing things for tomorrow, but also maybe designing those tools without even looking at how would they be used in the next 5, 7 years. But then the approach of problem solving in these two domains are very different. So I think a nice idea, people, even in your case, by combining design and technology, you try to fuse these two things and then see, they don't restrict each other way of thinking, but complement, so that we can solve both problems. I think I'm right now, most of my work is focusing on solving a problem which could be used in the field tomorrow. But that's purely my personal philosophy. I think in academia, there should be enough freedom, and that should be one of our major goals, to think about 2030, think about 2040, think about 2050. Yeah, I'll put it in this way.
Great. Thank you. I had lots of questions, but I think we should let you go. I must
Sure.
say that your office looks much nicer on video than mine. But it is, very nice. One thing common though is that I can see that there are lots of badges behind.
Exactly.
That you have been to. Yeah, so that's sort of similar. I have a bunch of badges also.
Yeah, certainly.
So thank you very much for taking the time
Thank you very
today.
much. It was lovely talking to you guys, and let's hope to keep in touch. And I'm happy to talk again whenever you like.
Thank you very much. Bye. Bye.
So as I